Okay, let's give you guys some more practice. So here, find the quadratic approximation for e to the power of x here. Near x equals 0. So near here. Okay, so your quadratic, well you could have somehow find the equation for quadratic so that it will be a good approximation near x equals 0. Or it could be like this. Or your quadratic could even be something like this. Okay, it's not a very good one, but it is possible. Um, well, I don't know. Well, find the quadratic approximation for this near x equals 0. So press pause and have a go. Okay, so to do this here, start out with your your quadratic will be in this form here. Ax to the power of 2 plus bx plus c. So your quadratic will be in this form here. So the trick is to well your quadratic will look something like this, maybe. Hang on. Maybe something like this here. So the trick here is to look. Well, we ultimately later will have to differentiate this and then differentiate the red line here and make sure that the gradient at this point here will be will be the same for both of them. And then we have to look at the second derivative for the black line, and then we've got to look at the second derivative for the red line and make sure that the second derivative or at this point here for the two graphs will be the same. Okay, so to do this here, start out with your quadratic here. So this is your f of x here, and then when x equals, sorry, when well we're going to put 0 into here. So when we put 0 into here, this whole thing here, well this here goes, this here goes, okay, leaving you just c. And then when you put 0 into here, this thing here will be 1. So we know that our quadratic will eventually have a 1 in here in the c. Okay. Now we've got to find b and a here. So the first step here is to differentiate it. So our quadratic will look something like this. Now, well, not well, maybe something like this. Okay, so the next step is to differentiate the black line here, and then differentiate the red line here, and set the two first derivatives to be the same. Okay, so the next step is to differentiate this. That will then give us this. Now and then looking at this, differentiate this. That will then give us this here, and then put 0 into here because we are evaluating it at x equals 0. So basically we are looking at the first derivative of the quadratic, and then we also look at the first derivative of the red line here. Okay, so this is the first derivative of the red line. This is the first derivative of our quadratic. So when you put 0 into here, this thing here goes, leaving you just b. Okay, and then when you put 0 into here, it was this here will be 1. So we know that here b, well we need to somehow set our quadratic in such a way that the first derivative of our quadratic will be the same as the first derivative of our original function. So meaning b will be 1. Okay, so far this has to be 1. And then b here will also have to be 1. Now we've got to find a. And the trick here is to look at the second derivative at x equals 0. So now look at the second derivative. So differentiate this. That will then give you this. And then differentiate this. That will then give you this. Now put 0, because we are evaluating it at x equals 0. Put 0 into the x here. That will then give you 2a. And then put 0 into here. That will remain the same. That will give you 1. So we now need to set the second derivative of our quadratic to be the same as the second derivative of our original function, which was this. So 2a must, well, the second derivative here has to be the same as the second derivative over here. So meaning that a has to be a half. Okay. So now looking back at this, our quadratic approximation will be given by this. Okay, because c here, oops, hang on, because c here is well, we worked it out to be 1. B here, we worked it out to be 1. A here, we worked it out to be a half. So this here is our quadratic approximation. So if you get a graph plotter and plot e to the power of x here, that's the red line here, and then this is our quadratic approximation. And then if you look at near x equals 0, it is a good approximation. Okay, so we can say that our quadratic here is approximately the same as the original f of x near x equals 0, and you can see that on the graph here, because near here the blue line is pretty much the same as the red line. Okay.